Hi, this is a small demo to show a prototype I've built of immediate mode DOM. That is a way to do DOM diffing without the virtual part. That is, you do the DOM diffing on the DOM itself as you build your DOM, which you don't actually build because you don't allocate anything. You just compare what you are attempting to render against the real DOM. The idea came a while ago while I was reading about immediate mode UIs. You should check it. Basically, it's a way to say kind of procedurally, or I don't know if that's the correct way, what your UI should look like, and the tool just renders that as you explain it. There's a really cool implementation in C++ called imGUI. I don't know how it's pronounced. Immediate mode GUI. You should check it out also. So for a long time I was thinking it should be possible to do that on the web with the DOM, because I'm kind of a performance freak and I love React and the virtual DOM, but I don't like that for every single render I have to allocate so many objects just to say that only a single part changed. So the main idea that will be shown in this demo is to tell to use an object to tell what you are going to render, building the tree. And as you are building the tree, that object is checking against the actual DOM on the browser and doing the changes as it goes. It doesn't wait until you build the whole DOM tree and then checks against the current virtual DOM tree and then calculates what it has changed and do it on the actual DOM. It just, as you go building your DOM tree, it checks for each call where you are and the differences and applies the differences. I built some small examples. I think they prove it works. It's just a proof of concept, but it should be enough to get you an idea. So I have 4 examples. One that just increments a number for each animation frame, that is 60 frames per second. And when I click increment, it increments a count. This demo has an interesting property that only allocates the strings for this node and for this node. That's the only allocations it does. This is the same, but the code is different because if you see the chain, I will show you the chain example, it's chained. So sometimes it gets really long and messy, and statements, it's a way to split the rendering in different parts. Switch places was a way to check that the DOM diffing was working well when everything was changing. So every time you click, I switch the top to the bottom. That way I have to regenerate a lot of DOM on the DOM diffing. And I wanted to see like complex nested things and removing. So I built this, which for each animation frame, it renders a table of 0 to 10 rows and columns. And this, what it does is it has to remove nodes when it goes back to 0. So I wanted to see if remove worked correctly. So now let's see. This does allocations, a lot of allocations. Well, a lot. Every time you shrink the table to the smallest one, you will have to reallocate the DOM nodes you want to render. There's a really simple optimization there. Just keep a pool of existing DOM nodes that you removed from the tree, and when you need one, you check if there's a node with that tag name and just reuse that. But it's possible, but I don't have time to do it. So let's see the code. Let's go to chained. The library is one object, 200 lines of code. Basically, it keeps you create a new instance telling where the root of your tree is, and it has some flags, and it has a cursor which is where am I right now on the real DOM, and it's a DOM node on the browser. You can reset it if you don't want to. For each request animation frame, you don't want to allocate a new one. You can reset the previous one you had to not allocate. Then I have methods to create the DOM nodes, tables, tbody, tr, td, div, button, span, p, and a text node. That is the text node that is inside a node. I didn't add all the other ones because it's just a matter of writing a macro. Well, I have a unique object, a singleton, that means my cursor is at no node. For example, when you remove the node. The child's method tells the library to enter to the childs of a node. Next tells it to move to the next node. On the DOM tree, you don't have to call next; it's called automatically in other methods. And means go to the parent. I'm finished rendering this node. Go to the parent. Text node, render the text node. Get parent node, returns the parent node because there's corner cases. Replace current with is when I compare the current node I have with the one I'm rendering, and they are two different tags. I have to replace the current one with the new one. Node is like a generic function to render a node. It first checks if the current tag name is the tag name you are trying to render. Then it checks that the attributes are the same. If the tag name is the same and the attributes are different, it will like replace the tags. And if it's not the same tag, it will replace the current one with the other one. In attributes, I check that the attributes you have are the same that the ones on the tag on the DOM. If not, I replace them. And I handle event handlers especially because I have to remove the old listener and put the new one if they are different. If they are the same on click but the function is different, I have to remove the current and put the new one. I do a trick there. I attach the functions on the node itself. Here I'm missing checking if the DOM node has attributes that you didn't pass, but it's just a matter of going the other way around. And here is just to create a node. That's the old library. It's 200 lines of code, and this is how it's used. The chained example, the one I use here, I just reset the immediate mode object, and I just say div, and I pass the attributes, enter the childs, create a div, enter the childs, create a p, enter the childs. This is the raw, the lowest level. It's like the assembly of immediate mode DOM. If somebody wants to continue or I continue, I will create a nicer DSL on top. But this allows you to not allocate anything. For example, if I did a nice DSL with lambdas and stuff like that, I will be allocating stuff. Then I render a text node. I end that tag. I open a span, enter the childs, render text node, go out of the span and go out of the div. Render a button, enter the childs, render the text, go out, enter a div, enter the childs, render a p, enter the childs of the p, enter a text node, a span, and end. Then I increment the loop node and render again on request animation frames. Render statements is the same, but I just I don't chain everything. I just in no particular place I just split because you can do like the builder pattern, and it will be nicer if my pretty printer didn't remove my special indentation. It will be easier to read. Here you can just call the object. Since it's a mutable object, you can just call it. It remembers what it is on the DOM tree. And the cool thing about this is that you can pass the object down to render functions that render a particular part. This render switch is just has an if the loop count is if the count of the button is odd, it renders in one order, and if it's even, it renders in the other order. And the table is the most interesting one because you would imagine it's the longest one, but it's the shortest one. I just reset the immediate mode. I enter the root div. I create a table. I create a tbody and enter it. And now I have two nested loops. One creates a row and enters the childs, and inside on another loop I create a TD and enter it and put a text node there and exit and then exit all the other ones. So this is the code to render that that table. Um, Here you can see how I could move this to an extra function, and I could move this to an extra function. I just have to pass this emode object, and the main only checks what you want to see. Um, so let's see now a little bit of performance. So let me remove this. I will start getting the performance and incrementing. And it's rendering 60 frames per second as fun. Well, not as fast as it can, because I did it with set timeout, but it wasn't faster because set timeout it's slower. And if you see the summary, all of this is idle. The script is not doing anything because it's finished. This is only scripting, this is rendering, painting, and system. So as you can see, I'm not doing almost no work. If you see the bottom-up performance, so which functions were called the most of them are internal to the browser. Layout function call for animation frame and the click, and animation frame layer, composite layers, update tree. And if you see here, this is really interesting. The first function that appears on my code is immediate mode, and the slowest part of the whole code, if you see on the left what it took, it's P, but mainly because of this. Setting text content is slow, is one of the slowest parts, and append child is slow. And also accessing the tag name is slow. Well, slow, it's 12 milliseconds in 10 seconds. It's not slow, but it's the slowest part of the whole code. That's really interesting. Where your performance bottlenecks in scare quotes, because I'm on almost all the time idle, are the browser and not your code. So let's see something that and let's see let's see the one that does the most job, which is this, because it's removing nodes and appending nodes a lot, which chain doesn't do. It only changes the text content. And we can see that it still is not doing a lot of work. It's doing a little bit more of scripting, because it's having to add and remove all these nodes, and it's doing more rendering because it's a table, but still it's like 80% idle. And in bottom up, we see again that we are nowhere near the top, and the first two functions from our code are append child and remove child, because yeah, we are doing that a lot. And they are not even ours, they are from the DOM. And the first one from us is rendering the nodes, because we are creating a lot of new nodes. And now let's go back to chain, and let's see memory, last thing, because that was one of the experiments. So I'm going to record heap allocations. And that's the JIT kicking in. Of course, some of these allocations are these strings, and that's the JIT kicking in again. And you can see that there are almost no allocations. And when I finish, the whole heap is less than 3 megabytes. And if we go to allocations, and we select, first we have to go to summary. If we go here and see what was allocated here, there was a better view of this, which I don't remember what it was. So see, system object is the most, which I think it's the JIT code, strings, arrays. I'm not creating arrays, so it's something else. And typed arrays. There was a view that showed that the allocation was mostly from the JIT. And yeah, you can see that there are almost no allocation. See the array, I'm not creating arrays. Closure, I'm not creating closures. System, these are like JIT stuff. Mouse events, because I'm clicking. Event, because I'm clicking. UI event, of course, because I'm clicking. And some objects, I don't know which are. But as you can see, I'm allocating almost anything, rendering at 60 frames per second, and the tool uh, does its job. And it's more interesting in places like the table example than the other ones. But of course, with a nicer DSL and splitting the rendering into smaller functions will make more sense. Will make it more readable. But I think it's a nice example and showing that immediate mode is possible on the DOM and that you don't need a virtual DOM. Thank you for listening this far.